a steel bar. A steel bar a steel bar having three sections, various L length, L2, L3, having different diameters, D1, D2, D3, subjected to axial load, P, having a Young modulus, a constant value, having a Young modulus. Now, to get the total extension of this steel bar, subjected to Texas axial load. To get the total extension of this bar, the first thing is to calculate the cross-sectional area of each section. The cross-sectional area of area 1 for first section is per d squared all over 4. For the second section is per d squared all over 4. For the third section is per d squared all over 4. So this is the area computation. So to get the cross-sectional area of each of the section of this T bar, there is the formula to apply. The next thing, 6 Young modulus is provided and the constant value. What's the Young modulus? Young modulus is stress all over strain. And what is stress? Is force all over area. What is strain? Is change in length all over original length. Now note, our force can also be present as P. So from this relationship, our Young modulus is equals to force all over area times L all over change in length. So finally now, PL all over area times change in length. So this is the formula for Young modulus. But we are looking for the total extension. So from this relationship, we can have Young modulus, which is force times length all over area times change in length, which is same as Young modulus times areas times change in length equals to PL. So my change in length, which is the total extension, will now become force times length all over Young modulus times area. So this is a formula to calculate the change in length of the steel bars. Now we have to calculate the total extension of this steel bar. Now the first we have to determine the change in length of each bars. So our total extension is change in length of first bar plus change in length of second bar plus change in length of third bar. So finally our total extension is PL1 all over Young modulus times A1 plus PL2 all over Young modulus times A2 plus PL3 over Young modulus times what? A3. So my total extension will now be the common factor is P all over Young modulus. So finally, L1 all over A1 plus L2 all over A2 plus L3 all over A3. So this is the formula to compute the total extension of this T bar. So this T bar is subject to axial load P, having L1, L2 at their various lengths, D1, D2 as their various diameters. So the first thing is to compute the area, the cross-sectional of each section. The 6 Young modulus, the constant value is provided. So Young modulus is stress over strain. So we have to derive this relationship. So this PL force times load times over area times change length. Then from the Young modulus relationship, we can derive our total extension formula. So note, to get the total extension is a change in length of this plus change in length of this plus change in length of this. That will give us total extension formula. So finally, to get the total extension of this T-bar is load all over Young modulus, all the jacket, L1 over A1 plus L2 over A2 plus L3 over A3. Thank you very much.